Lab 7 lab lecture for transient behavior of capacitors and inductors. As we now start studying capacitors and inductors, differential equations will need to be set up to analyze their behavior. This means we first have to derive the differential equation from first principles, mainly using KVL and KCL. Next, we derive the initial conditions, which are typically labeled as IC. As a passing remark, both of these steps are not done in your differential equations or Math 7 course, but will be required in circuits. Then we solve for the solution, that is, the capacitor's voltage or the inductor's current, and then we make the solution real by applying the initial conditions to it. Then we interpret the solution by plotting the voltage and current versus time and interpreting what that is. What we will be doing in PSpice today is only trying to interpret the solution by plotting voltage/current versus time, because at this point we don't have the skills to actually solve any of these problems. Now I want to set up PSpice to show you how to simulate an RC and RL circuit. To set up for PSpice, I want to do this RC circuit example where I have a 3-volt source, I have a 3 and 2 6-ohm resistors, and a 0.05 farad capacitor. And when I want to analyze the behavior of the voltage of this capacitor. So here's what we got to do. There are 2 times that we got to consider. The first time is that if I'm at a time between -infinity and 0, this is called t equal to 0 minus. 0 minus means before the switch is thrown. What happens to this circuit? The capacitor has had an infinite amount of time to charge and therefore acts like an open. So the circuit then looks like, since the switch is open, that 6-ohm resistor is dead. So then if this is an open, then that means no current flow, so there's no voltage across the 3 and the 6-ohm resistors. Therefore, the voltage of the capacitor must be the same as the source, and that's 3 volts. The initial condition, that is the IC of the capacitor, is therefore Vc of 0 minus is equal to 3 volts. Now the switch gets closed. At t equals to 0 plus, that plus sign means that just after the switch is thrown, there's a sudden change in the circuit and the capacitor changes how it is charging up. This circuit now has the 6-ohm resistor, whereas previously it didn't. This voltage of the capacitor, as it changes with time, is known as the transient behavior of the capacitor. This is the thing that we are most interested in, and we will spend a considerable amount of time solving for this in chapters 8 and 9. At t equal to infinity, the capacitor is fully charged up and the final circuit looks like this. I have an open capacitor. This 6-ohm resistor that was here, since this is an open, there's nothing here. So therefore, the voltage of the capacitor at t equal to infinity is the same as the voltage of the 6-ohm resistor here. So I can calculate what that number is using voltage divider rule. VDR then says that the voltage of the capacitor at t equal to infinity is 2 volts. So when I look up here, it started at 3 volts. When I look at t equal to infinity, the voltage is now at 2 volts, so therefore the capacitor discharged during this process. Plotting Vc versus t, we know that before the switch is thrown, the voltage is at 3 volts. And the other thing that we know is that at Vc at infinity, we know that it's 2 volts. So that at t equal to 0, there's a sudden change in how the voltage is behaving here, and so now we look at the transient behavior as the capacitor goes from 3 volts to 2 volts. And from physics 4b, you either know that a capacitor is charging up exponentially or discharging exponentially, but that's not important right now, but this is the shape that we should see in PSpice. Now let's go in and actually look at what's happening. I now have PSpice open and I want to set up the circuit that I just showed you guys. So I've gone in, I got my sources, my resistors, and my cap, and now what I'm going to start to do here is that I'm going to wire this thing up. The thing that I have to add here is the switch. So I'm going to go and search for the switch. So it starts with SW, and note that it comes up immediately as I did SW_T close. So let me place that guy in. So I'm going to place that guy, and what you want to get is you want pin 1 to be up here at the top, pin 2 to connect down here to the bottom. So I'm going to rotate this guy till I get 1 up, then I'm going to come in and insert it. And so now, I don't know if that wire's right or not. Okay, there it is. That looks good. So now what I want to do here is that I want to set the initial condition to the capacitor. We already saw that the initial condition to the capacitor was 3 volts. So if I double click on the capacitor, I get a window, and then I'm going to go look for the IC. And then in here, I'm going to type 3 volts. And then I'm going to go back to the page. And to simplify things here, I'm going to go over to the right, and I'm going to get what's called an off-page connector. So I'm going to pick the left. So I'm going to pick the left off-page connector. And then I'm going to place it at the node of the capacitor. And then I'm going to type in capacitor for this thing. So when I go and search for the voltage of the capacitor, it's going to be fairly straightforward for me to find it when you have all these voltages. Now I want to set up to run the simulation. So I need to edit the simulation so that I can do a time transient behavior of the capacitor. So if you go next to the Run PSpice button, there's a little pencil that edits the simulation process. So if I click on that, you're going to find that the default is the bias point. What we're interested in is a time domain analysis. Now what we want to do here is that I'm going to set my runtime to 1 microsecond. And then the maximum size step that I'm going to do here is I'm going to say that I want to take something about, if I have 1 microseconds, I'm going to come in and I'm going to take 100 points for my plot. So my maximum size steps is 100th of a microsecond, which gives me 100 points. I can always come back and adjust this. So I'm going to apply and I'm going to say OK. So now I'm ready to run the simulation. So I'm going to run it. And I'm going to go open the probe window, which is flashing. And what you're going to get here is this big black screen. So what I'm going to do here is that I need to add the plot of the voltage of the capacitor. And if you come over here to add trace, and I do the drop-down menu, you're going to see that you're going to get lots of choices. Like, we don't care about the power, we don't care about the current, we only care about the voltages. But if you scan through the voltages, you could see that there's quite a few voltages. But if you look for the voltage of the capacitor, it's very easy to spot. So if I double click on this, what you're seeing here is that you're seeing that the capacitor, which started off at 3 volts, then decays down to 2 volts in this amount of time. What I want to do now is that I want to start to analyze this curve. So one of the things that's really unfortunate in PSpice is that these grid marks can be overwhelming. So what I'm going to do here is that I'm going to do a right click. So one of the things that I want to do here is that I want to be able to get numerical values off this curve. So the first thing that you got to do is that you got to come over here and you got to toggle to get functions that allow you to look for things. And when you do this, I'm sorry that this is so small, but that's what my surface is doing. So what we want to do here is that if you look carefully, there's a piece of binoculars here. So if I bring the binoculars, there's a way that you can search for values. So what I'm going to do here is that I want to get the voltage at 0.5 microseconds, which is along this line right here. What you can do here is that you could type in the following value, SFXV, and that stands for search for X values. And the value of the X value that I want to look for is that I want to look for 0.5 microseconds. And if I hit OK, you're going to see that it gets to that point exactly. Now, if I want to mark what that voltage is, there's a mark label point, and if I click on that, I now have the value of that voltage. And if I unclick the cursor right here, what you're seeing here, I now have the voltage at, 0.5 microseconds, and that value is 2.917 volts at that location. Another thing that you can do here is that if you try to plot this curve, it's going to be very thin. So if I come over here and I go look at trace properties, I can actually change the thickness of the curve. Let's say that I pick it right here, and I can even change the color of the curve. So if I look at this thing here, you could see that I've now made the curve orange, and I have this voltage value that's given. Now, to be able to print this onto like a sheet or something, one of the things that you can do here is that if you click on Window, you'll see that there's a command that's called Copy to Clipboard. If you click on this thing, it automatically changes white to black and black to white. So when you click on that, that's now in the clipboard. So now that I have it on a clipboard, I could then move to a program, let's say Word, and I could come in here and I can paste it, and you see that I have my curve right there. So now we've set up PSpice and printed out V of capacitor versus time. So your job now is to go do part 1 with the inductor. Part 2, the pulse input to RC circuit. We are now looking at trying to produce this square wave. It turns out by having a square wave like this, we can get rid of switches. And so this is essentially a very, very, very good switch. So what we're doing here is that we're going to use this voltage source to act on this resistor and this capacitor. So the first thing that we got to do here is that we need to look at this voltage source that we have to create. So this is V pulse, and you could see that V1 and V2 represent the bottom of the pulse and the top of the pulse. TD is the time delay, so we're going to set that equal to 0 because we want that thing to start at 0. And then the time to rise and the time to fall, well, it turns out that there's no such thing as a square wave like this in PSpice. So what you have to do here is that you have to make the rise and fall time very, very, very small compared to the pulse width. And the pulse width it's also known as the duty cycle. It's when is the voltage on. So if you come back up here, that is when the voltage is on. This is when the voltage is off. So it's on duty here. It's not on duty there. And then the period tells us how long it takes before it goes from this time to that time. It's the period of the wave. I'm going to go set this up for the previous PSpice circuit that I used, and I'll change the values just a little bit so that you could see how that is set up. Let's go to PSpice. Here's PSpice, so now I'm going to modify this. So I took out the short, I took out the voltage source, so now I'm going to go search for V pulse. You could see that I typed in V pulse, and you could see that it's down here in the image, so now I'm going to go place this guy. So to set my pulse width, I'm going to start my pulse at TD equal to 0, no time delay. my rise and fall time have to be small compared to my pulse width. And in this case, since this is 1 microsecond, I'm going to say that my rise and fall times are going to be 0.01 nanoseconds. And then I want this cycle to repeat every 2 microseconds. My voltages now, my V1 I'm going to set to 0, and V2 I'm going to set to 3 volts. So now let's go do it in PSpice. So now what you're seeing here is that I have V1, V2, my delay of 0, my rise and fall times as 0.01 nanoseconds, my pulse width as 1 microsecond, and then my period as 2 microseconds. This time I want to show you some additional tricks here. I want to go back and get my off-page connector, and I'm going to pick a right one, and then I'm going to go place this right one here, and then I'm going to place one more right here, and then I'm going to rotate this guy. I have 2 off-page connectors, so I'm going to call this guy here source, and the other one here I'm going to call voltage of 6 ohm resistor. And then I'm going to wire this guy to this node because that's what that is right there. In general, I want to pick names that are longer so that when I go and look for them, they're easier to find. Since my period is 2 microseconds, I need to go and edit the simulation. So when I edit it, I was only running it for 1 microsecond. Let's say that I'd look at 2 cycles, and I'm going to run that for 4. So now I have 4 cycles that it's going to run. Now that I've set up the circuit, I want to go run it, and then let's go display it. I want to add the voltage across R1, but note that I defined nodes V source and V6 ohm resistor, so it's got to be the difference between these two to get the voltage across R1. And then the voltage across the cap, since it's measured relative to the ground, it's just this minus 0, but I'll ignore the 0. So let's go back into the probe window and do that. So what I can do here is that as I add these new traces, I'm going to add the cap, and then I can put a space here, and then I can do a little bit of algebra on the window. So I'm going to say source, and then I'm going to put a minus V resistor here, and then when I enter that guy, what you're seeing here is that, well, one, I'm not seeing the R behavior here, but that's okay for right now. You will when you do it in part 2. And what you're seeing here is that I start at 0. The voltage of the capacitor, which is in red here, goes up to 2 volts, and then it decays all the way down to 0, and then it charges up and down up to 2 volts, which is exactly what we expected from the previous circuit. Now, if I go and I look at the voltage across that 3 ohm resistor here, you could see that this guy's not maximizing all the way to 3 volts, but only sees 1 volt. So I am simultaneously plotting 3 different voltages. Now you go and set up PSpice with vPulse in the circuit that's given in the lab handout, and plot it out and see if you can get what you expect to see from the image that I have on there. For part 3, don't do it. So then I want to go to the end of the lab handout. Here's what I want you to do. So go look at this circuit here and see if you can wire this thing up and then plot it. And all you want to do is that the whole goal is just to plot this thing alone. So once you do that, print it out, and then just from looking at the picture, see if you can explain a little bit about the behavior of the capacitor. as well as the resistor here. But don't try to mathematically solve these things. Just look at it by saying, what was the initial voltage of the capacitor? What was the initial, current of the resistor of the 1K? Of the 2K resistor. And then turn in parts 1 and 2. Remember, 3 is not there. Okay, good luck. Send me a message if you have any trouble.